Welcome, undergrad engineering students, to today's Lab Explainer. Today we're actually going to move way beyond basic, unstructured text. We're going to learn how to systematically organize web content using the absolute powerhouse that is HTML5. I am super thrilled to be your guide through Lab Program 3, because we're going to build something that isn't just visually clean, it's structurally sound right down to its core. Okay, so here's our roadmap for this practical experiment. We'll start with our lab aim and essential tags, then cruise right through the procedure for execution and get our hands dirty coding semantic HTML5 elements. After that, we'll look at building lists and tables, observe the output of all our hard work, and wrap it all up with our lab conclusion and results. Sound good? Let's dive in.
Section 1. Lab Aim and Essential Tags.
So, what is our primary aim today? Well, we're going to create a web page using specific HTML5 elements to organize and present content effectively. And look, we aren't just making a page that looks okay-ish on a monitor. We are demonstrating the practical application of organizing web content for both robust presentation and, honestly, critical accessibility. It's all about writing smart, meaningful code from the very first keystroke.
To pull this off, we're relying on a core set of essential tags. We've got the usual suspects, lists, using ordered, unordered, and list item tags. We'll construct tabular data using standard table row, header, and data tags. We'll embed some images too, and this is a big but. We are focusing heavily on semantic HTML5 elements today, specifically the section, article, and aside tags. Trust me, these are going to be your absolute best friends for superior content organization.
Moving right along to Section 2, Procedure for Execution.
The execution process here is beautifully straightforward. Step 1, we just script the raw HTML in a basic text editor. Something simple like Notepad. You absolutely do not need a massive, heavy integrated development environment for this. Just a clean canvas for your code. Once you've typed it out, just save it with a .html extension. Then Step 2, open that newly saved file with any standard web browser. Boom! The browser does the heavy lifting, rendering our code into a visual web page. All right, Section 3, Coding Semantic HTML5 Elements. Let's look at the code itself. In our HTML snippet for today's lab, really pay attention to how we utilize specific semantic tags to logically group our content. We're relying on section for large thematic groupings, article for independent content, and aside for supplementary notes. Notice what we're not doing? We are deliberately moving away from meaningless generic layout containers. That endless, confusing sea of div tags. Semantic tags explicitly tell the browser, the developer, and assistive technologies exactly what the content actually means.
So, the crucial point here is understanding how to nest these properly. Let's distinguish between the two main ones. A section tag acts as a broad thematic wrapper. In our lab, we apply structural borders to it using CSS to group big concepts together, like web development technologies. On the flip side, an article tag holds independent, self-contained information nested within those sections, like our specific dictionary-style definitions for HTML and CSS. Think of the section as a book chapter and the article as a distinct essay right inside it.
Onward to Section 4, Building Lists and Tables.
Check out how our program neatly contrasts these two vital list formats. We use an ordered list, that's the OL tag, to define numbered sequences. This is perfect for when you actually need to rank items, like our top programming languages. 1 Python, 2 Java, 3 C++. But contrast that against an unordered list, the UL tag. We use that for bulleted items in non-sequential groupings. So simply listing web technologies like HTML, CSS, and JavaScript, where the order doesn't really matter.
Now, data display requires a bit more rigidity, right? To display our student details, we construct a table row by row. We start with the table tag and then use TR for our rows. It is vital, literally absolutely vital, to define clear column headers first using the TH tag. So we set up role no, name, and department. Only after that do we populate the individual data cells using the TD tag for students like Rahul and Priya. This gives us that predictable, clean, accessible grid.
Section 5, Observing the Output. The fun part.
Okay, notice how the browser applies our CSS borders here to visibly separate the content chunks. It's really cool. You can clearly see the thick border creating our broad web development technology section.
But look closely inside that bounding box. You'll see the individual article blocks for HTML and CSS cleanly separated by their own lighter borders. The structure we meticulously typed in the back end is now perfectly mirrored on the front end.
And this next part brilliantly illustrates the semantic code working for real-world user experience. The aside element we coded, it's rendered right here with a distinct gray background and a dark left border. That visually screams, hey, I'm a supplementary note, separate from the main flow. Following right below that, you can see our perfectly formatted ordered list with its numerals and our unordered list with standard bullet points. Clean, legible, and highly organized.
Finally, taking a look at this last output screenshot, it confirms that our student details table is properly structured with its rows and bold headers totally intact, and it's sitting perfectly right just above that correctly sized SRM logo image. Every single thing is exactly where our code commanded it to be. No surprises here.
Section 6, Lab Conclusion and Results. Let's wrap this up.
As documented in our final lab report, I'd call this a total success. We have successfully implemented and visually demonstrated the practical applications of these core HTML5 structural elements. The lists, the tables, the images, and those all-important semantic tags, section, article, and aside, they all perform perfectly. We didn't just make a web page, we engineered a page that is logically sound from the ground up. But before we totally dismiss the lab, I really want you to consider this question. Beyond just visual organization on a screen, how does our use of tags like article and aside fundamentally change the way screen readers interpret our web page for visually impaired users? Remember, a generic div tag tells a screen reader absolutely nothing, but a semantic tag? It tells an assistive device exactly how to navigate and announce that content to the user. Good engineering isn't just about what you can see, it's about making information truly accessible to everyone. Keep that in mind as you head into your next coding session. Thank you so much for joining me for this lab explainer, and hey, happy coding!